Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 18th, 2025, so about 4 days ago. This paper presents a new, open data set that achieves a geometric mean score of 4.53, which is higher than any public alternative. The paper is titled, No Humans Required, Autonomous High-Quality Image Editing Triplet Mining. And the implications for how we train powerful image editing models are really significant. This work automates the creation of training data, specifically the millions of before image, instruction, and after image sets needed. On the Hugging Face page, you'll find the 14.7 billion parameter model weights and see examples of its impressive image editing, like changing a plane's material to feathers. So to really show what this automated pipeline can do, the first figure gives us a look at the final product, the NHR edit dataset. We see examples of these triplets I mentioned, which are sets of an original image, an instruction, and the edited result. They're grouped into object, human, and ambience edits. For instance, it can add a tiny toy taxi to a street or change a person's entire outfit. The impressive part is that these were all generated and then validated automatically, using specialized multimodal large language models. So, how do they actually create these triplets? This next listing shows the very first step of their automated pipeline. It starts with a detailed text-to-image prompt, which is the text used to generate the initial, or before, image. In this case, a living room with a cactus and other items. Then, the system automatically creates a set of corresponding editing instructions, like, get rid of that cactus. The key is that this entire process, from generation to validation, is automated using specialized multimodal large language models, which are AIs that can understand and process both text and images together. Building on that automated pipeline, this table really gets to the heart of the validation step. It compares different multimodal large language models on their ability to assess edit quality. We see two key metrics: mean absolute error, or MAE, which measures how far off an AI's quality score is from a human's, so lower is better. And Spearman's row, which checks if the AI's ranking of edits matches a human's, so higher is better. The key finding is in that last row. A fine-tuned Gemini 2.0 Flash model dramatically outperforms the others, showing a specialized validator was essential for the pipeline's success. So how does that specialized validator fit into the bigger picture? Well, this diagram lays out the entire automated pipeline. It starts by generating prompts and edit instructions, like a kitten with rings, and change the kitten to a green parrot. Then, it creates a bunch of before images and tries to apply those edits. The crucial part is the multi-stage filtering. First, the general model does a rough pass. Then, that specialized fine-tuned Gemini model we just talked about makes the final call, scoring edits on instruction adherence and aesthetics, and only keeping the absolute best results. So, to wrap things up, this entire automated pipeline demonstrates a powerful new way forward for image editing models. The biggest takeaway is that by creating and fine-tuning a specialized validator, an AI that becomes an expert at judging image edits, researchers can completely automate the creation of high-quality training data, removing a huge bottleneck. This led to their new model, trained using a technique called low-rank adaptation, or LoRA, a very efficient method for fine-tuning. This proves that fully automated data generation can create state-of-the-art results. That's all for today. I'm Alex, and this has been the AI Research Roundup.